How's it going, YouTube and fellow aerospace engineers? Today I want to share with you a project I've been working on called Airfolio. This is a airfoil database search engine which I developed out of a need for a faster, cleaner airfoil database. There's definitely some good options out there, such as Airfoil Tools or Bigfoil, so shoutouts to them since I've used them many times. But I really wanted something that was a bit faster and a bit more clean and minimalist, and bringing airfoil databases into the modern web dev environment. So this is a database built on a JS framework called Vue, but that's not important. What's important is to show you this homepage. When you land on airfolio.live, type that in your browser, you'll land right on this search page where you can immediately start searching for airfoils and get near real-time feedback as soon as you type. Airfoils and airfoil options start populating here. On this homepage, pretty minimalist. There's just a couple random airfoil selections that show up every time you land. There's a donate now button in case you like the project. Please feel free to donate. It helps me keep developing these tools. But anyways, back to the search engine. Let's say you want to search for a NACA airfoil. You can type NACA, search. It does a text search. All the airfoils in the database. Here we can see we have 115 results. I haven't included every single possible permutation of NACA airfoils in this database, but here's just a couple of the popular ones. If we type, let's say, Epler, you actually have to filter by category for Epler. Let's go here. You'll get all the Epler airfoils that are available. You can filter them by thickness. Let's say you're working on an aircraft design project and you know you need an airfoil of about 10 to 12% thickness. Well, you can type that in the filters and you'll immediately filter out all the Epler airfoils that are between those ranges. So pretty cool. I can say, let's say I want a little bit of camber in my airfoil. Well, let's do 2 to 3%, and boom, now we have about 10 options. They load near instantly. And then you can pick your favorite one. For the sake of this example, let's pick the E211. That one looks nice. So when you go onto the airfoil page, you'll see the thickness and camber values, as well as leading edge radius, how many nodes are available or points are available in the file. If you click this points button, it'll show you a table where that you can copy and paste anywhere you need it. But one of my favorite features is this Bezier curve fit. I'll let that run. But basically what I do in the background is I fit a 6th order polynomial to the points in the airfoil file. And with those control points, now you can basically recreate this airfoil inside of your CAD program without having to bring in all 200 or 400 airfoil points. You only need these 12 points. 6 for the upper surface and 6 for the lower surface. And this gives you the added benefit that, let's say you bring this airfoil into your CAD program and you want to just change one of these slightly, well, you can move it in your CAD program a little bit and very quickly modify the airfoil. Very cool capability. A lot of configurators like this. If we scroll down on this page, you'll see a bunch of different Reynolds numbers that have been ran. So you can see somebody ran a 1.4 million Reynolds number case all the way down to 100,000 Reynolds numbers. So, these performance data that we see in this table is cases that have been ran by users. So it's very cool to see all of the cases people are looking at. You can quickly deselect all and only show 1 or 2 of these and start comparing the different Reynolds numbers. And if you don't like the available performance data that exists in the database already, you can run a new one. Let's say we want to run 200,000 at an end crit of 5. Since nobody's ran that before, there should be a new analysis. I will hide everything and only show that new one I ran. And boom, there it is. And you compare that versus, let's say, 400,000, and you can start seeing this data. So it's very neat, very quick way to analyze airfoils. Now let me talk a little bit more about that performance analysis. How did I do that? Am I running Xfoil or what am I doing? So if you go over to the tools and the performance compare page, this is the page where you can compare the aerodynamic performance of multiple airfoils at once. But at the top, there's this hyperlink to Airfoil. Now, Airfoil is a neural network developed by Peter Sharp, very smart guy here. He's at the intersection of software, neural nets, and aerodynamics, and he's created this neural network that's trained on Airfoil data. So you can see the different input parameters he varied and the different outputs that he tracked, and basically trained a neural network on that. So given some airfoil shape, you can actually predict the performance in almost real time. So this is, again, grounded on Airfoil, but a neural network. And what I did is I took that open source code, I plugged it into the back end of this app, and now I use a neural network to very quickly estimate the performance data for multiple airfoils. So let's say I'm going to select, a couple airfoils here and compare their performance at 500,000 Reynolds number. We'll just leave all the defaults. Boom, we get all the performance, and you can start seeing their lift curves, their drag curves. I can click enlarge plots, disable data hover, and start seeing trends in the data. Now over to the left, there's a few filters that I like to use to filter out candidate airfoils. So let's say you want a long endurance aircraft, so you need high L over D. Well, I can turn on this max L over D filter and filter out any low L over D airfoils. You see that? So now I'm only left with 3. And let's say I know what my design CL is. I know I want a design CL of, maybe 1.2 at 5 degrees, just for the sake of this demo. Well, this design CL actually filters out airfoils by the design point. It's very cool. And you can imagine you can do this with up to 300 different airfoils and filter down their performance. If I reset the filters and then show all airfoils down here, I like to show the summary table. The summary table shows a couple important parameters. Sometimes the neural network will fail and you'll get this NA, or just rerun the performance analysis. But we can see things like max L over D in this table, minimum drag, and the neural network confidence. Now this one's a very important column. This column tells you how confident the neural network is in its performance prediction. Higher values are obviously better. And I tend to see that at low end crits, the neural network struggles a bit more. So anything above 90, you can be, really confident in, and then above 50, you probably want to spot check it, and then below 50, 50%, I would completely just discount that data. Great, so that's the performance table. Now the scatter plot is one of my favorites because let's say you're trying to balance L over D and CL max for a particular airfoil. Well, you can filter this down. You can say, okay, CL max on the x-axis, max L over D here, and we can kind of get almost like a Pareto front, an optimization front of, okay, CL max and L over D. So we can say that, oh, we want a higher CL max airfoil, but we'll give up some L over D, or we can pick this with a slightly lower CL max, but better L over D for our design. So a bunch of very cool features in this app. I don't have time to go over all of them today, but if you enjoyed this video, please let me know in the comments, and I'll be sure to do a follow-up video where I talk about some of these other neat tools that I've implemented in this website. All, again, built out of my own necessity for rapid aerodynamic trade studies. And again, if you like the project, please, please, please donate. Go to this page, donate $1, donate $2. It really helps me continue to develop these projects and pay for the database hosting costs. I don't have any sponsors, so I'm doing this all of my own free will. So with that, I'll leave you and see you in the next video.